Question 29. And we are given a quartic function x squared minus 5x plus 2 all multiplied by x squared minus 5x plus 4. In the question we are asked to find the four roots of t of x, and it also says giving our answers to three significant figures where necessary. This first quadratic, if I factorise this and get the roots, or rather if I solve it here, those will be two solutions for the whole thing, and similarly here. The nicest thing to do would be to factorise this into a paired brackets and these into paired brackets, but this one won't go into paired brackets. There's nothing that can multiply to give 2 that could add up to give minus 5. Therefore, I've got a situation where I need to use the quadratic formula. And that was hinted to me in the question where it says to three significant figures. If I use the quadratic formula to find x, I'll be taking minus b, and b is minus 5, plus or minus the square root of b squared minus 4 times a, which is 1, and c, which is 2. No, I substituted the negative numbers into brackets, but didn't trouble with the positive numbers. And on the base, I've got 2 times a, and a is 1. Putting this into my calculator, I would get two answers, one for the positive and one for the negative. And to three significant figures, those are 4.56 and 0.438. And those are two solutions for this part of the quartic, and thus they're solutions for the quartic as a whole. However, I have got the second quadratic on the right there. Starting with that, I can factorise this into paired brackets. And this gives me two more solutions of 1 and 4 for x. So here are my four solutions. And that's all that's required for part A. But in part B, we are asked to sketch the graph of y equals t of x, showing clearly the coordinates of all the points where the curve meets the axes. Now, my first point is minus 0.438. Excuse me, positive 0.438. Then 1, 4, and 4.56. Additionally, I know the general shape of this because if I expand the x squared and the x squared term, I get positive 1 x to the power 4, showing the general shape will be like this. If I expand the constants, I would get 8, and that would be my intercept here. So, that's the general shape, a positive cubic, intercept at 8 found by expanding out the constants, and the x-intercepts given from my solutions to these two quadratics that make up the quartic.